I get kind of obsessed with it because the model can't be made better if you don't look at the errors
Right.
for weeks, really just for weeks. You can find me for a large percentage of the year just staring at the outputs of my models, feeling bad. That's kind of what my work looks like. I
Hmm.
think that theme is universal for any machine learning model. I would love to just have a class in every grad school that's called Error Analysis and You, a lifestyle.
Hello, everyone. Welcome to the Data Scientist Show. Today we have Sergey Feldman. Sergey is the head of AI at Alongside, providing mental health support for students. He also works part time as a lead applied research scientist at Allen Institute for AI. Previously, he worked on a ML model that improves search relevancy for scientific literature. Sergey has a PhD in electrical and electronics engineering from University of Washington. Today we'll talk about machine learning for search relevancy, his consulting project for the Gates Foundation, AI for mental health, and career lessons. Make sure you listen till the end. If you like the show, subscribe, leave a comment, and give us a 5-star review. Welcome to the show, Sergey.
Thanks, nice to be here.
You called yourself a machine learning skeptic, and I know you worked on machine learning problem a lot. So, what is a machine learning skeptic?
I think it's in response to other people mostly. When I'm by myself in a room alone, I'm a machine learning agnostic where I don't really know what's going to happen if I press run.
Hmm.
But often I did a bunch of consulting work, and I think it felt like I had to push back against folks to say maybe it won't work. I don't know. There's a lot of assumption that magically machine learning or AI would solve their problem. And that was a number of years ago. Nowadays, it's I think even more impressive what machine learning can do, and the dreams are bigger. So being a skeptic nowadays is harder, I think. You see
Hmm.
new models like Stable Diffusion or GPT-3, and it's just harder to stay a skeptic when they just look really impressive. So I feel like I might have to put that identity on a shelf somewhere. It just seems harder to maintain.
Yeah, I think what you meant is when we work on, say, tabular data, when we try to get the business insight. When we try to solve the business problem, machine learning is not always the best solution.
Oh yeah,
And
almost, yeah. Often it just isn't. Often you need to plot your data and then notice you have nothing to do at all, and you should just move on to something else because you haven't collected the right data yet, or there's so many ways that it's not useful.
mhm. Previously, we talked about the projects you worked on at Allen Institute. So, machine learning for search algorithms. Can you tell us a little bit about that project?
Sure. This was in 2020, so it's a bit ago, and we had we had a non-machine learning search engine on Semantic Scholar, which is an academic scholarly search engine. It was just based on Elasticsearch, which is the first thing you should try, and that's what they had. And it just kind of wasn't working well for most folks. So I tried to make a new one. And I'd never made a search engine before, so I just thought it would be pretty easy, which is a great first mistake for everyone to make for every single machine learning project, as far as I can tell. Um, the goal was to take our search logs, which we'd had for about 3 years at that point, and train a model that re-ranks the top Elasticsearch results. Now we were hoping that this model would just kind of work off the bat. It just sounds like the best practice in the field. We weren't using BERT or anything at the time. I think some of the advances in the ease with which you can use BERT and other transformers to re-rank, it was just too slow. And Semantic Scholar is a nonprofit, so we chose LightGBM, which is a very fast gradient boosted decision tree ensemble package. Works really well. And that was the goal, just to see, can we take our search logs, fit this large GBM model, and re-rank the top results, and that would work great. Of course, in practice, you just run into all kinds of issues and reasons why that doesn't work at all.
What was the challenge in the data set?
Most data doesn't look like you'd expect. So folks would search for an entire paper title. It's an academic search engine, so they would find a paper title, they'd paste it in. The first result would be the paper title because exact matches are still pretty good, and they would just not click on it. They click on the second or third result.
Mm.
So we might imagine why that is. Maybe you've already read that paper and you just want papers like it, and this is what you decided to do. You thought, hey, if these are the words in the paper title, I'll just find some other papers like that. But to a machine learning model, you show it an exact result and then no clicks. It just gets confused. It just looks like noise. And there would be similar issues with you'd search for an author, but then not click on any paper the author wrote. You'd search for a venue, but then not click on the venue that paper came from. So a large percentage of the data, I think I remember I removed about 30% of it, was just irrational from a perspective of training a machine learning model, which, we would want it to have certain behaviors. We would want it to provide the best match first, which is just a simple idea for search. You just want the keywords to match, but the data itself was noisy and we didn't know why. So we did the opposite of what you'd normally do. Instead of adding more data, we removed a bunch of data. We just filtered out data that I personally said, this doesn't make sense. If I was searching and this happened, I wouldn't like this. So I just wrote a bunch of rules about what I wouldn't like in my data, and it just removed a bunch of it and then improved things quite a bit.
For example, what kind of rules did you add?
Well, if you're searching for, let's say, deep learning biomedicine, I want papers that have both those phrases to be ranked above papers where only one is ranked, for example. It's very simplistic stuff. It's nothing, it's just thinking about how do I distill what I care about in search. If you search for an author name, you should, and then the papers you clicked on aren't by that author. Well, that data is just not useful to me because I don't know why you clicked on it. I would just imagine situations where I can't figure out what the person was thinking and remove it. Because if I can't figure it out, LightGPM is not going to figure it out either. It only has access to certain features that we design. So
Yeah. So basically, from a user's perspective, you added some rules, helps the algorithm to output something that's more relevant in this context, not just like a generic search algorithm, but for people who looking for research papers.
yeah, and there's a very specific set of uh, entities that they care about. Titles, abstracts. We're not searching full text in Semantic Scholar. Um, Venues where this was published, and the author field and the year field. So I had to treat those fields separately in the algorithm. We had to care about all of them.
Yeah.
There's also one other rule that I think is important, which is that when people search for papers, they want papers that are highly cited. It's a signal of quality. It's kind of like a original page rank in a way, where, hey, if lots of people refer to this paper, it must be good. It's mostly true. Sometimes it's not true, but so if there were two papers that are equally good matches in terms of nine-phrase matching, like they both match deep learning for biomedicine, but one of them is way more cited, but they clicked on the other one, we would drop that one. We would want the more cited one to be above. Again, it's all things being equal. This isn't always true, and often you do want less cited papers. But the machine learning model doesn't suffer if you do that. It just learns that you care about the citation signal in a less noisy way by having that data be more present and more representative as opposed to data where the opposite is happening, right? Because it's trying to learn a pattern, and the pattern should be easily detectable or as easily detectable as you can make it.
Yeah. And I'm curious, so when you add those rules, and when you put a model in production, and when the new data comes in, how do you make sure the rules you added are actually good? Or has there been any cases where you have to, I don't know if it's the right word, to tune or maybe like adjust the rules or adjust the weights of the rules you applied?
We haven't actually. I think I've been keeping my eye on it, and it seems to be okay. Those rules were just for the training data. We also have some post hoc rules that we apply after the training, which kind of encode the same thing. So I think you're asking about those, and they seem okay. They're very simple. That was the goal, is you don't want them to be complicated. Some of the post hoc rules are things like the quoted stuff should be above the non-quoted stuff. which is just encoding the basic dogma of what people expect in their search engines nowadays.
Mm-hmm.
So because they're simple, model drift is not an issue as much. But I'm sure if I sat down and spent another 4 months on it, I'd discover that more tweaking and training needs to happen. It's just there's so many other things to do that we just haven't gotten around to it.
Yeah. And what are you learning using the tree-based models in this search relevancy problem?
Yeah, so there's a set of features. I think now more time is spent dealing with learning rates, but I still like to do old-fashioned feature learning. So there's just a handful of features, something on the order of 20 or 30, and they're trying to capture matchiness importance. So there's features like what percentage of the query is matched in the title or the abstract or the venue. What is the log probability of the match? And this, we have an old style model, and it just emits this probability of the match. So probability in English language, this is in academic papers, we train this probability model. It kind of tells you how surprising a match is. So you might imagine that the phrase, therefore we show, appears all over the place in academia. So it's not very surprising. So that match gets downweighted. Whereas a match such as, I don't even know, some kind of protein name next to another protein name in a rare arrangement would have a very high probability. And this allows the model to learn that uh, rarer matches are more important, which is very important for the user, right? They may type a lot in the search bar, but they care more about the stuff that's more niche, probably. Not always, but probably. So that kind of feature turned out to be very important, and without it, the model struggled to tell the difference about what mattered. The other features that we have are citation count, like I mentioned, and this thing called key citation count, which is a little model that runs in Semantic Scholar that tries to infer how many of those citations are ones that really matter. They're not just token citations. Oh, we cite this paper, but we cite this paper and it was important for our work to even exist. Those are the kind of features that are in there. And I started with way more and had to remove them because they didn't work for reasons I don't always know and caused strange noise. And
Mm-hmm.
it was all the standard machine learning fun you'd expect.
Yeah. And previously, you talked about the decision to actually remove some of the data. So, how do you decide what subset to remove?
Oh, I just fit a model and it was terrible, and I kept looking at the outputs and for days. Really, it was just wake up turn on my computer in the morning and just start looking at model outputs over and over and over and make notes. It was this kind of relentless error analysis, which is basically most of the machine learning job, as far as I can tell, is whatever it is you fit, first 7 models don't work, you just look at what they did wrong and then try to think, why would they do this? There's always a reason that it doesn't work. In deep learning, the reason can be that a model didn't converge or didn't learn. In light GBM, that's not the issue. It always converges and learns. The issue is the features. So you think, what is it about my data and features that could possibly cause this model to learn this thing? And then you start querying the data to try to understand which subset of the training set could have resulted in combination with the features I chose in this issue. And you just chip away at it. So you change the features a little, you change the training data a little. Maybe you augment the data, you add more training data, and you see if that works. But then in my case, it turned out that removing stuff was way more important than augmenting it.
Yeah. And nowadays, with all the machine learning tools and packages, like you mentioned, it's easy to train a model. A lot of our work is in getting the data, feature engineering, and do error analysis. And when we try those approaches, you might have different versions of data and models. And I remember when I was working on those type of analysis, I would have data one, model one. Sometimes you want to do the analysis fast, you don't always check in version it. I'm kind of curious, how do you manage the whole error analysis process?
Poorly. I don't have the discipline to use good tooling around this. I rely on the fact that I seem to be able to remember enough of what's going on to know which notebooks are what, but most of my management is carefully naming my notebooks and Python script. That's it. I wrote so it'll be O1, import the data from SQL. O2, consider the data filtering process. O3. If I just do that, that seems to be enough. I assume at some point I will just get overwhelmed and fail catastrophically, but so far I've managed to avoid learning new tools. It's hard to find the time to learn a new toolkit every 5 months. I
Yeah.
think despite how wonderful they are, and there's a lot of great tools out there constantly being made by people and put open source. It's really an amazing ecosystem to be a part of. But naming files carefully is where I've landed at this part of my career.
Yeah. And can you give us some best practices in doing error analysis?
Yeah, I think the first thing I do is I just write a simple function that prints out stuff. It just prints out, here was the input, here was the output, here were the features in the input, here is what the output looks like in all its glory with lots of dots in between. Just something that really makes it easy to press enter and just see the next error. And that doesn't take very long. It takes an hour, and it's really worth it. Once just writing that puts you in a mode where you can quickly go through, and that really is the fact, is how quickly can you look at the errors, edit your model, and retrain. Very often, especially for deep learning, the retraining part takes forever. So it'd be nice if you could find a smaller model or a subset of your data that could give you comparable performance just to do debugging on. Maybe you want to use some gigantic model, but you might still be able to debug on a smaller model with a smaller data set. Not always. Sometimes they won't learn. But this is why I feel like I'm addicted to old school machine learning, because it trains in 1 to 7 minutes. I don't really have time to just completely forget what I'm doing and lose my motivation. So then I can come back and do error analysis for an hour instead of waiting
Mm.
for 4 hours and then doing error analysis for an hour. Because then you only go through 2 cycles in a day. I can go through 5 cycles in a day. And this kind of quick speed of a cycle is really the key. It's hard to imagine doing this for 3 months, but you can imagine doing it for a week. And if it takes you 4 days to train your model, well, then you really are looking at 2 or 3 weeks of error analysis just to get somewhere. And that's too
Hmm.
slow for people. It doesn't fit our psychology. It's not enough progress. Whoever your manager is might say, it's been 3 weeks, what have you done? And you can't just say, I've been doing error analysis, although maybe that's what's needed. It's hard to make that justification to people.
Hmm.
So shortening the cycle is very important. It's not always obvious how to do that, but just going in pursuit of that goal. I'm sure there's some good blog posts on that.
Yeah. And sometimes for example, if you work on video data, the data processing part or the training time could be longer. Or if you have a large data set. So, what are some advice you give people who can take to shorten the cycles?
Yeah. Subsample the data set and see if you can still train a model that's reasonable. Often the lowest hanging bugs can be found on even a crappy model. You don't need to
Mm.
fit your best model to find a lot of the worst bugs, because they're bugs in your code or really noisy data. So you can certainly often find those on using smaller models and less data, which makes everything faster. The
Mm.
other thing, of course, is don't just fit a model in your data without looking at it first. You have to do some exploratory data analysis, ask some questions, and just look at it for a long time. Spend a whole day doing nothing but staring at the outputs of your data, make notes about what you see. A lot of times I'll go back, I'll have this notepad plus plus of notes. Again, nothing fancy, it's just
Yeah.
very simplistic. And then I'll see, okay, there's this type of issue in the data. Later I'll go back and I'll see, okay, the model has made these mistakes. I know why. It's traced to this issue in the data. I'm not going to remember that, but I noticed that people click in this way, and now I'm having problems. So I can go back and check my notes about why the data is not perfect.
You give a talk on nested cross validation at Pi Data Conference. Can you tell the audience what is nested cross validation and why you think people should use it more?
Yeah, that's my favorite topic. So this really applies when you have small-ish data or very, very large compute. So not for everybody. But let me start at where machine learning dogma is. You have a training set and you have a test set. And if you fit your model on your training set, you need another data set to evaluate on. Otherwise, you'll be overly optimistic about how well your model did, because your model is going to do best usually on the data it fit. So it's not realistic. What's called nested cross-validation, where you use each piece of your whole data set as a test set, not just the one piece. This is very nice because you get a variance estimate of your generalization performance, how well you did on the test set, and you also get some estimate of how well your model trains differently. So you could look at your learning curves for your different trainings and see with the same learning rate what happens. You also find out that you might have different learning rates that are arrived at because you perform cross-validation now multiple times, once per test set. So I have a talk with some diagrams you should look at if you're interested. But if you have a small enough data set and your models run quickly enough, you should always do this. It's never a bad idea, and you often will discover that, oh, 7 different learning rates work on my model. There isn't one good one. Or for one test set, I have this amazing performance. I was going to write a paper, but for my second test set, I have horrible performance. That happens a lot, especially for tiny data sets. You have an expensive data set that you collected from a randomized control trial somewhere. You have 2,000 subjects. You really need to do nested cross-validation. Otherwise, you might find that one test set that you chose by accident has excellent performance. You were going to write a great paper, but the other ones don't. And this is because the data is so small. There are a lot of heterogeneity in small data, especially one that comes from people and real complex processes.
And going back to the search problem you worked on, how did you do the model evaluation?
Oh, yeah. It turns out that evaluating the model on a standard search ranking metric, it's called NDCG, there's other ones. It seemed like the model quality, from a perspective of me using it, had nothing to do with the metric we were using. So you take two models, one had a higher NDCG, one had a lower NDCG, and the better one didn't look better. So when I used it, they both looked terrible. And we eventually came up with an approach where we hand labeled 250 queries, and we had conditions that they had to satisfy. So we searched for each of these queries in 3 different search engines: Google Scholar, Semantic Scholar, and what's called MAG, which isn't around anymore, Microsoft Academic Graph. They shut that down. And we said, how many of the top 3 results satisfy these criteria? They match the noun phrases in the query, like deep learning or biomedical. They match the authors in the query, author names, the venue, the year. They rank order the citations in a way that makes sense. So there is a paper with more citations that is a better result. And so we had these little check marks for each query that a model had to satisfy. These were kind of tests, basic tests. And so our actual evaluation set wasn't click data, even though that's what we were using to train. It was this custom test metric that said what percentage of my queries and results satisfy these things that I say they should be able to satisfy, because one of my 3 search engines could do it. And once we started hill climbing on this, it became much easier to get the model to perform better, because the model had to literally satisfy visually what I considered to be good results for a keyword academic search. And not just me, we had other folks helping with the annotation and such.
Yeah. So let me see if I understand it correctly. So when you're training, you use one metric, and when you on the validation set, you use a different metric.
Yeah, not standard at all. I mean, if we could have hand labeled 1 million of these, that really would have been better. But we can't. It takes too long. It took like 2 or 3 days for 2 or 3 people to do this. 250 queries. You really have to sort of squint at it, issue the query in 3 different search engines. But despite the small number, it was much, much more useful than the clicks. One nice thing about this is it comes with an explanation of the error, right? We have these 5 check marks. If it fails one, you know which one it failed. So I would be able to categorize each model by the types of failures it makes and how many. So this model would make a whole bunch of failures in the citation ordering, while this model makes a whole bunch of failures in the noun phrase ordering. And that also gives me information to change the features. If the citations are failing, well, then I got to look at the citation feature. So it helped speed up everything. to be able to have the explanations. But first, we had to stop everything and label a bunch of data for a while.
Gotcha. But labeling the data in the validation set is still faster than labeling the entire training set.
Yeah.
So that's why you still use the metric, which is not perfect clicks to train the model. And then when you do the validation and analysis, you use the metric that's more relevant to the actual use case.
Yeah, and we ended up with this much smaller validation and test set, unfortunately, but it was enough, I think. I mean, it's not perfect, but we kept working at it until we thought the number of times it would fail us was acceptable to us as people who had become really annoyed. We just became these highly annoyed people, and we figured most of the users are less annoyed than us who've been staring at this for months. That I hope that's true. Who knows? Maybe the real users are more annoyed. We've had fewer complaints about search.
Yeah. This is a very interesting way to validate the model. Have you read any like papers or blog posts when it comes to large data set which is not well labeled? Has other people using similar approach?
I think a lot of the search literature for real search engines is sparse. Giant companies don't want to publish how they make their search engines.
Right.
And there's not a lot of other small search engines that aren't off-the-shelf tools. So we were kind of in this interesting in-between zone where we wanted to make a search engine over 200 million documents, which is a lot, but it's not Google scale or Bing scale. But off-the-shelf wasn't working for us.
Right.
There really weren't that many references. There's an entire very robust academic search literature, but it's not made for people to use. They have data sets that they just optimize. There's MS Marco. That's a big famous one for Microsoft. And a lot of the work is, can we make this number go up by a bunch? But it's never put in front of users to say, at what point did this number go up enough so it's good enough so they don't need to use these kinds of techniques? We were explicitly targeting user satisfaction. So making a user satisfaction proxy as validation made sense after a while. It wasn't obvious immediately. But I haven't seen a lot of other stuff like this myself.
Yeah, because of data or specific business requirement, we have to be creative to come out with solutions, even if it's not taught in the textbooks or found in the literature. So when you create a new solution, do you worry, oh, what if it doesn't work well or people criticize this approach? Am I taking a risk? How did you feel when you make the decision, when you come up with something new?
I feel good about it. I mean, my main concern is disappointing the users, right? Academia has this, you're writing a paper, people are going to read it and maybe cite it. So the audience is unfortunately pretty small for most papers, unless you have a magically big paper. But this search engine has probably been used by, I don't know how many people, tens of thousands, maybe a couple hundred. I have no idea, a lot. And then I don't want to disappoint this anonymous crowd that I will never meet. That to me is a bigger risk. So just trying crazy stuff, it's fun because if it gets me to this point where I'm happy with the model, then I figure other people will be happy with it too. And then I really don't worry about how nutty or unused the technique is at all. I just worry about, making a whole bunch of people disappointed in my work. That seems like that makes me feel really bad. I don't want that to happen.
Yeah. And a lot of times when we work on different type of machine learning projects, we use different kind of approach. Something you do in one project might not be useful for other projects, but across all the machine learning projects you work on, do you find there's some common theme or say philosophy that you always follow?
Yeah, I think it's just error analysis. I spend a lot of, often when I speak to folks who are a little more junior, I find that I have to talk about that a lot. It seems very natural to me. Like, how could you make a model better if you don't look? But often it's not the case for everybody. I think it may be in school it's not emphasized. That's what I have to infer based on meeting folks earlier in their career. I get kind of obsessed with it because their model can't be made better if you don't look at the errors.
Right.
for weeks, really just for weeks. You can find me for a large percentage of the year just staring at the outputs of my models, feeling bad. That's kind of what my work looks like. I
Hmm.
think that theme is universal for any machine learning model. I would love to just have a class in every grad school that's called error analysis and you, a lifestyle. I think there's kind of this amongst data scientists, which is a very related field. There's
Yeah.
this idea you'll spend 90% of your time looking at data. They
Hmm.
say, or setting up your data pipelines. It's not fancy or there's this kind of theme. In machine learning, there's actually a similar theme. It's you'll spend 90% of your time looking at model outputs, but it's not as much of a cliche yet. I would love to make it more of a cliche.
Yeah. Yeah. I'm looking forward to see your error analysis lifestyle course.
Yeah, yeah.
When you work with people, you mentioned more junior people. What are some mistakes you see they make when they do error analysis?
Just underestimating how much time it takes and how many you have to look at and how much hand labeling you do. Sometimes error analysis for me just ends up being an annotation project. I will start a spreadsheet and I will start annotating 100 errors, and for each one, I'll put a category of error type. And at the end, I'll count them up. I'll do this, it'll take a day, and then I'll have this distribution of error types over a very small portion of the data set. But often you'll see that, 40% of my errors are because of this one thing. And then you focus on that one thing and you do it again.
Mm.
And you take another 100 and randomly annotate. And if you do this 5 times, it'll take a long time, but your model will be way better, just way better. Especially if you solve each problem, you can just solve each problem by just continuing to look at stuff. There isn't any particular recipe for the solution. Often by looking at the data, you will just come to think, oh, I think I know how to fix this. And there's no shortcut to that process where the idea of I know how to fix this appears only after exposure to the errors themselves for X amount of time.
Mm.
It's a little harder for deep learning because when your model hasn't converged, no amount of error analysis is going to help you figure that out. You have to look at the model weights. It's a different set of problems that I'm kind of skipping over here, but I think it's a big problem right now because deep learning models are, you know, taking over the industry, at least publicly. I'm sure lots of people privately are still using older, faster, cheaper models.
Yeah.
And that kind of analysis is very similar. It's just harder because looking at the weights, they don't have any semantic meaning, right? You have to come up
Hmm.
with clever ways to try to figure out why didn't my model converge? Why is there 5 nans in my output? It's just harder.
Yeah. Have you used any open source libraries or Python library to help you with error analysis, or do you
Oh yeah,
write your own scripts?
I use SHAP a lot, the SHAP value library,
Hmm.
especially for feature-based algorithms. For deep learning, there's all the visualizations, and there's a lot of good libraries. But yeah, the SHAP values are useful for feature-based libraries. They show you a distribution of reasons why a classification or a regression was made,
Hmm.
and it's useful to see, oh, it's the model really learned to rely on this feature. That's not what I expected. That's weird. I can examine this feature.
Yeah.
Um, it's kind of like looking at the weights of a model for deep learning where all the weights are concentrated in this on these inputs. That's a little weird. Looking at
Hmm.
the attention distribution of what is the model paying attention to, but for feature analysis.
Yeah. And I previously talked to some founders. They build a company or tool to help people with error analysis. They help you tag the data and then tell you what part of data is not working correctly. And then one question I ask them is, if you kind of similar to what you do yourself, you look at what type of subset of data doesn't work very well, and then you try to improve it. So how do you know you're not like overfitting the model? Because there can be different ways to slice the data. There will never be a certain way to make all subsets of data perfectly predicted. How do you decide, how do you prioritize?
I have two main techniques that I use to make sure I didn't sort of overfit to this training set that I've been working on for too long. One is trying to get a very simple UI for the model. Like when we were doing the search model, we made a stupid little search engine that I would never
Mm.
show anyone, and I would just issue searches. and the searches would go against our production database, and we would see what happens. So if it looked like there was something weird going on, then I would go back and try to see if it was because of the training set. The other thing I would do is, after doing all this work, I would try to get a new training data set entirely if I could. So like a held out training, which is the opposite of, sort of a strange way to do it. But if you have more training data around somewhere, go get that and retrain everything and see what happens. It shouldn't be that different now. You've done all this tweaking, but often, like you said, it's true. Your tweaking was specific to that training set, and now things have broken. So just having more training data that you can pull out towards the end of the process is really useful to see how much of your process and tweaks is local to this particular training data. That's also very useful because later when you're going to do retraining for a production model, which you often have to do, it might break because it was overfit to the training data, and this would be a way to prevent that from happening.
So previously you worked on consulting projects with the Gates Foundation. Can you tell us more about the project?
Sure. I was a consultant of the Gates Foundation part-time for over 6 years, I think, maybe 7 years. I was originally hired on a team that was given the goal of reducing neonatal and maternal issues in low and middle income countries, or LMICs as they're called. And I was brought on as the ML person. So this was, 2015 or something, and I think ML had been getting quite popular, but no one quite knew what it was good for, especially in global health situations where there was a lot of standard statistical techniques that were being used. The data was small but expensive to collect. The statistics were very specific and well targeted, and there was a question of, can we use ML to do something useful? And the Gates Foundation occasionally makes fairly large bets on high risk things, so they just hired one person to try stuff out. That was my job. There was a lot of data that they had that had been collected very expensively. They would set up a center in rural places in Bangladesh or something, for example, and they would follow women from early pregnancy through birth and through the first 3 months of the life of the newborn and collect all kinds of data. So this would cost $20 million, and you'd have a data set that from an ML perspective looks tiny. It's like 2,000 rows and 150 columns. So this data set cost $20 million, but so now it makes sense to spend more time modeling to see what you could do. And a lot of the work was, what can we predict here? We have logistic regression and other statistical techniques that were well known, but do nonlinear models do better? If I apply the light GBM or XGBoost here, what happens? Can we predict preterm birth better? Can we predict hospital readmission better? These were all questions that nobody really had an answer to. I just sort of tried stuff out for a long time. And mostly the answer is no, you can't. But sometimes the answer is you kind of can. There's a few applications where a nonlinear model, an ML model, is a lot better than a linear model. But it's really just a search process where you have to just look at the data, and it's very noisy because these kinds of collections are hard to do.
Yeah.
You're living next to people. They're not always going to show up for their appointments. They have stuff going on. So there's a lot of missing data, a lot of outliers because tired people are manually entering things in computers. So the data is as noisy and as missing as you would expect for any real data set. So there was just a lot of classic data science ML lifecycle work where you get a data set, you don't know what's going on, you talk to the experts once a week for an hour and say, what does this mean? What does this mean? What does this mean? Read a bunch of papers about biology or collections, or try to understand the collection protocol to figure out what's going on. And then when you fit an ML model, then you go back to the expert and say, here's what I did. And then they have to understand you. And they have a doctorate in something else entirely. They're very smart people, but they don't know what SHAP values are. So you got to explain it.
Mm-hmm.
And I learned a lot about communicating with people who don't already know what I know. It was very useful, which isn't something I learned in grad school. I guess not surprising.
Yeah.
So it was a very interesting piece of work. I thought I learned a lot, and I hope it was helpful to the folks. There's going to be a paper coming out from one of the projects for those with, has 100 authors or something. I'm lucky to be one of them.
Mm-hmm. So when you were looking at the data, trying to figure out what are some problems that would be useful to solve? How do you decide which one to move on? Like, how was your selection process look like?
I really put that in the feet of the experts. They had goals. They've been working on this for 20 years, and they really had a strong idea in their minds of what was important and what wasn't. And so I spent a lot of time just asking them. I really tried to put as little as of my own judgment on it as possible. I would say if you could solve one problem predictively for the purpose of deploying a cheap unit in the field that could help practitioners on the ground, what would you do? So I would sort of just ask them like for user stories in a way, except they had very specific users, right? They were like, I want a box this big that can predict preterm birth, and I want to be able to query it 4 times, and then from that I would reverse engineer what I thought were reasonable things to try, because some things are too expensive to collect. You can't use you can only collect ultrasound twice at most, right? So how many times can you use an ultrasound to get predictions? You can't use the 7 ultrasounds you have. You have to fit a model that works well from 1 or 2.
Mm-hmm.
So I would just quiz my collaborators and make decisions based entirely on that, give them very regular updates, and do comparison to the kind of models they're familiar with. And if we're just not getting any traction against those models, just say this isn't going to work.
Yeah. And you mentioned you realize some ML models, they're very obviously they're performing better than linear models, even after you applying for like lasso or other techniques. So do you have any examples of what kind of use case you find machine learning models or tree-based model perform better than linear models?
Yeah, there's this one project called the Chain Project. That's the one that's going to be published on. There's a bunch of kids in the hospital, and you're trying to find out if they're going to die in the hospital. So it's a very severe and serious. So you have all these measurements. One thing, it's a very data-rich environment, the hospital. The kids are being measured all the time. There's blood tests, stool samples, things like that. So you have a lot of features. I think it was in the hundreds or maybe even 1,000. So there's some feature selection going on. And your goal is to rank order the kids by risk of death. So you have all these kids in the hospital, and you could have an ML model running that's pretty cheap that you keep updating, and they'll just sort of output the probability. And the area under the ROC curve for those models was in the 0.8 range, while the linear models were in the 0.6 or 0.7 range, which is a big improvement.
Yeah.
So there were some nonlinear interactions and all the complexity there that if deployed, I hope, would provide the local nurses and doctors some triage warning about, well, the model's saying this kid's at more risk, so maybe you should devote more time to them. And that's really the only thing the model would do. It doesn't sort of tell you definitively. It just helps professionals triage a little bit. This is hypothetical. I don't think anything's been implemented. But that particular case was, I think, the most successful one, where the difference between the linear and the nonlinear was the largest.
Yeah. And for this type of model, the outputs could change how the practitioners take care of the kids, and could affect kids' life. So how do you do some error analysis or take feedbacks when you launch the model?
Oh, I don't know. That's for the UI folks. I really don't have the right expertise to say that. I think a lot, especially in the medical field, the UX is incredibly important. From what I understand, doctors and nurses and other medical practitioners have very difficult jobs, and technology can easily knock them out of their rhythms that make them effective.
Yeah.
So I've heard of cases where a new model that looks good is introduced into a doctor's medical record screen, and they don't use it at all because it doesn't work well with their actual flow. So, the ML model could be predictive, but if it's not properly integrated into a person's actual, real, stressful life, they're not going to use it.
Right.
And I don't have it. I don't have the expertise to know exactly how to do that.
Mhm.
It's always fun to work with UX folks because they have an intuition about where a human would click or not that I just don't. I just don't
Yeah.
have.
So when you work on this project, there are user researchers working with you on this.
I don't think so. I think this was upstream. This was a more academic first step exercise to demonstrate rigorously that this works and makes sense and try to understand what it's learning. So there's a lot of SHAP value analysis in the paper because as an academic paper, people want to say, well, what did the model learn? You look at the linear model, you're like, well, that coefficient's big, so. But here, that's not enough. So we fit a complex pipeline that would take the SHAP values and then cluster them together to give you profiles of types of risky kids. And then the practitioners who know what they're talking about would analyze these clusters in the paper, and they would have phenotypes of risky kids.
Mm-hmm.
So we had a close collaboration between the ML tooling and the professionals interpreting it. And I think that's what made it successful.
So when you work with healthcare professionals, they might not understand what is SHAP value or machine learning algorithms. And you mentioned you learn a lot by thinking about how to communicating with them and explaining things. So what is your approach to explain those technical terms to people don't have the background?
There are two things that I do. The first one is I make PowerPoint presentations or slides or whatever, and I think very carefully about what would someone who isn't me not know. It's so difficult to put
Yeah.
yourself in the mind of another person. First, I assume they're smart and capable, which they are, and then I say, being smart and capable, what's all the jargon that they don't know? What's complex about this picture? I just try really hard to think like the person and then make a PowerPoint presentation that would work for me. It
Mm-hmm.
doesn't always work because it's just sometimes the cognitive gap is too large. I fail to imagine myself as another person.
Yeah.
Standard, it's hard to do. The other thing is I try to make sure to have an attitude so they feel comfortable asking me questions and don't feel, people might say, oh, I should understand this already, or I'll look stupid if I ask this. I just try to do everything I can to make sure they understand that that is not the expectation. You shouldn't just understand stuff.
Mm-hmm.
That we're both people, and it's okay for you to ask me questions, and I'm going to ask you a lot of stupid questions. Often that is the case where I've already talked to them and I've asked them 300 questions, and hopefully that means they feel comfortable asking me some questions, but I try to be explicit about it.
Yeah.
I'll say, this isn't understandable. I haven't understood everything about you. You should just ask me questions. I won't think poorly. Just try to be informal about it. Don't put on a kind of tone, remove the arrogant. There's just a lot of human stuff that I tried really hard to do. Of
Mm-hmm.
course, I don't succeed all the time, but I really try to reduce the arrogance there and say, this stuff is complicated. If you don't get some part of it, that's okay. Just tell me. And then
Yeah.
that's our goal here is to move forward together. I also don't understand most of what you do.
Right. Yeah, this reminds me of Andrew Ng's machine learning course. I remember he always say, if you don't understand it, it's okay. It took me some time to learn this in the first time. I feel it really make people feel comfortable, and they also feel motivated to learn more and understand more. So recently you worked a lot on ML for healthcare. Can you tell us this startup you founded and what made you want to do this?
Yeah. Um, there are three co-founders, and I'm sort of the fourth one. And in April, we started a company called Alongside, which makes a mental health toolkit for teenagers in an app form. And it's sold to schools, and the schools make it available to their whole student body. And it's composed of a number of things, but the most important central piece is a kind of chatbot that is carefully written by our clinical experts who are therapists, psychiatrists, folks like that. And it has a little bit of machine learning sprinkled throughout to help make it more responsive, more conversational for the kids to use. The goal is to help people middle school and high school to have some capacity to self-service and deal with mental health issues that don't require necessarily a professional. So
Mm-hmm.
it's not a medical product, but you might imagine if someone loses a beloved pet, but they don't really want to talk to an adult. And based on our interviews, a lot of teenagers don't want to talk to adults,
Mm.
especially school counselors or maybe their parents. They just kind of don't want to talk to anyone. This is a safe space where you're talking with a robot into the void. What you say is private. You can say whatever you want. No one's going to judge you for it. And we write these scripts that, depending on what we think is going on with you, they guide you through a set of steps to try to help you feel better or more in control or calmer or understood or any number of these kinds of empathetic responses that have to do with your issues. And the issues people have, they're overwhelmed with schoolwork, with college applications. Their families are stressful. Their houses are stressful. Their friends are stressful. It's all the stuff you might remember from being a teenager. It turns out I barely remember, but it all rings true. That none of that stuff has changed. I just think now it seems like teenagers are more comfortable with talking to a robot on their phone than they may have been when I was a kid, when there were no robots or phones. But yeah.
Gotcha. So most of your work, is it around making the chatbot providing more relevant conversations?
Yeah, the biggest model we have is the model that tries to figure out what you're feeling and why you might be feeling that way. So if you tell us that you got too much homework going on, then we'll think, okay, this kid's probably stressed. The ML model would output this. And the category of issue is homework. We have a category for homework. And then depending on those detections, we'll choose a script to go through. So this script might be about, we'll ask a follow-up question. Is it because of procrastination or is just too much going on? And they'll say, okay, it's procrastination. We'll have a procrastination skill building script that kicks in. And that one has very little machine learning in it because I don't trust GPT-3 or ChatGPT to do this job. It's just too risky. It's too much of an issue if it sort of randomly talks to you, right? It doesn't know, there's no long-term plan in these machines. If you want to say, what's the best hike, it might be able to find one for you. But if you say I'm procrastinating, it'll just spit out this long paragraph of advice, and it's not really that useful. Having it spread out and professionally written by our counselors and therapists and such, they're doing a very careful job. They spent a very long time making sure that they're providing information one piece at a time, asking follow-up questions. They're really helping the kid through this process. And then, we read a handful of these chats after they're properly anonymized. And if they look bad, we fix them. That we just go through this process. Again, it's error analysis, but
Yeah.
much more high stakes error analysis where
Yeah.
we're talking to a human, a vulnerable person, and we need to make sure we don't make it worse, first of all. So you can't guarantee that with ChatGPT. It might make it worse. You have no idea. So do no harm, even though we're not a medical outfit. We're first to do no harm. And second, we have to think, what are they thinking? Why didn't this work for them? And the ML is very sparse there. It's really, we're taking the approach of not ML first, ML last, where we have an approach which is human driven, and then we think, where could machine learning help here? And it turns out it's helpful only in a few places. One of the places is we try to detect when a kid's messing around. So we might ask them a question and they might ignore it and say, hey, what's your favorite color, robot? And we have a model that detects that kind of messing around and says, I'm a robot, I don't have a favorite color, or my favorite color is the rainbow, and goes back into it. So that kind of model, it kicks in very rarely because most kids aren't messing with it. A few of them will, but those are the two major ML models we have now. We also have some machine learning in-house that helps the counselors do their job. It's often have to say, they have to ideate. When they're writing their scripts, they have to think, what's a good way to write this? And after 7 hours of this, you might just be tired. And then it's good to have something like GPT-3 to come up with variations for you to spur creativity. Then you take what you like and rewrite it and make sure it's good. So I think it is helping them do their job as writers, but we're not putting that stuff in front of a kid ever until it goes through a bunch of human eyes first.
Yeah, that makes a lot of sense because ChatGPT scrapes the entire internet and the information provided to you is not catered for this specific audience. I mean, I see a lot of people, they kind of tune the prompts they send to the algorithm, but I feel it's not going to be something the same as a doctor or therapist write down some similar scripts unless there are a lot of private consultation therapy script published out there for the algorithm to learn.
There are not.
So I think chat, like you mentioned, those type of large language models can be assistance of a therapist to come up with the answer. But what cannot be learned by ChatGPT is their decades of years of experience talking to a real human, provide advice. But if you think about, if you train this chatbot, say after certain years, train based on the scripts written by a lot of therapists, do you think it can work as sort of ChatGPT for therapy?
Maybe. I would hate to make a prediction on this, but probably if OpenAI decided to spend $1 billion paying therapists and their clients to collect entire transcripts of
Mm-hmm.
sessions and then have those therapists carefully annotate those sessions, who knows? I think it's not out of the realm of reason, but therapy isn't a simple thing. It can take weeks, months, years. And what happens that changes throughout those years?
Yeah.
It's a deep intuitive understanding from the person, from the therapist, and the client in their relationship. I'm not sure you could write that down. If I was to look back over my life and think about where has my mind changed for the better, where I've gotten less unhappy,
Yeah.
I don't know if I could point and say, here's what happened, here's what happened. And that's kind of what reinforcement learning needs. It needs some way to trace back the signal to what mattered. But mental health is really maybe one of the most complicated things that happens to a human. It's their basic function of their consciousness. So this might be the last thing to get solved, but I'm sure there will be a therapist-like product that is kind of effective, but I'm sure it'll be much worse than a human. But maybe having a personal coach where every morning you log on and it asks you how are you doing, and you'd say feeling a little overwhelmed today, and it kind of spits out some very basic things like do 5 breathing exercises, or do some push-ups, or repeat after me, or here's a video of you talking about yourself when you were feeling good. That sort of simple version, I could see that working for some people.
Yeah, it makes sense. We'll see how it works. I think in the next few years, things gonna change very, very quickly. I also wouldn't make a prediction, but I feel ChatGPT 3 could be something like AWS, kind of like a service to give different industry and organization, and they can use it to train their own data. For example, maybe a therapist scripts or confidential documents for a certain law firm that you wouldn't be able to scrape out externally, but you can use the same algorithm to train for yourself. Maybe that can shorten the time to proceed some legal process, etc.
Yep, I think that's happening right now. There's a lot of startups right now working on all that stuff, but it'll be very interesting to see who succeeds and
Mm-hmm.
how our lives will change in response to that. I already
Yeah.
use a Copilot a lot. It's made my
Mm-hmm.
life a lot easier, probably 20% efficiency improving in coding. I
Yeah.
know there's all kinds of ethical considerations and licensing considerations, and I hope those get resolved to everyone's satisfaction. In the meanwhile, I'm using this thing, and it's like it saves me so many Stack Overflow searches every day.
Right. So now, from a PhD student in engineering to the head of AI and senior research scientist, can you maybe give us an overview of your career? How did you get into machine learning? How did you grow to a leadership position?
The machine learning story is a little funny. I started, let's see, at DePaul University in Chicago doing something called management information systems. This was advice from family. They were like, "You'll make money." That was, and I didn't know what to do, so I just said, "Okay, I'll just
Yeah.
take your advice," having no internal motivation whatsoever. And I started taking a Java class, and it really just hated it. I just hated it. So I quit, and I transferred to another university, UIC, to do electrical engineering, because after I Googled electrical engineering, it said there were many different types of jobs. So it allowed me to continue not committing to a career.
Mm.
And then I was taking a bunch of electrical engineering classes, and I took something called digital signal processing, which studies the Fourier transform, and which is a technology underlying things like FM radio and basically all communications.
Yeah.
And I just thought it was fascinating. I really liked it. So I took every class I could in the signal processing track, and I ran out of them. Then I took a grad course, and I liked that too. So then I just started applying for grad school in electrical engineering and signal processing. But it's a mature field. There weren't many people doing DSP research. But I did find that in electrical engineering, there were a lot of people doing machine learning research. This was 2006, which I had never heard of before, because in 2006, it wasn't on the front page of the New York Times every other day. AI wasn't something everyone just talked about.
Yeah.
But I'd never heard it before. So it sounded very similar. They're both forms of applied math. It's a lot of sort of coding in MATLAB. MATLAB was what I was using at the time. And so it looked close enough and interesting. And I liked one of the professors that I spoke to at University of Washington a lot. So I came here to do machine learning knowing nothing about it. And only because I'd failed to find a signal processing research group that I thought was interesting. So then I just studied machine learning for a while, and it was really fun. And then I got a job at a startup, didn't like having a boss, quit that job, started a consulting company by myself. It was just, I was just really bouncing around. I convinced my friend to quit his job and join me at the consulting company. And then we consulted for a while. No commitments, no leadership, just meeting with people, asking what they needed, and delivering what they needed over and over again. That's how I got the Gates Foundation work, and I worked there for a while. It was interesting.
Yeah.
Eventually, I started consulting at the Allen Institute because I knew someone there, or I forget exactly how it started. And then I really liked that work because it allowed me to get back a little bit to academia because I'd stopped doing research. And I missed it a little bit. It was nice to just kind of see what you could do. Applications and consulting are very, very fixed. You just do the best thing you can. There's no time to discover new knowledge. Just, we're paying you by the hour. Quick, quick, quick. And I just really liked it. So I eventually converted to working there as a part-time employee. And how the leadership position? Oh, I don't know. Just kept doing stuff, I guess, over time. Eventually, you start caring about things enough that you ask people to help you, and it just sort of looks like leadership, but I'm not sure leadership is the right word for exactly where I am. I just like to do stuff with other people, and I have a lot of opinions. And when you put those together, I think it might look like leadership from the outside.
Yeah. And it's funny that previously you mentioned you didn't like having a boss, but now I guess as head of AI, you probably manage people. So how do you make sure other people like you as the boss?
Well, I've succeeded in not having people to manage. So I end up running projects, but I don't have people that report to me that I have to do their yearly reviews. So I think I've continued on that trend of as unhierarchical experience at my work as I can. And at the startup we just started, I may have a fancy title, but I don't know nobody works for me.
That's really cool. You're able to maintain this way and focus on what you're doing. I think it also takes a lot of self-awareness to understand what you really want and what you don't really want, because a lot of us see other people go into a company, get promoted or become a manager, and then sometimes we just, in our mind, the options is just a few, or our road is really narrow, you have to pick. But knowing what you like and be really good at what you want to do, and you can carve out your own path.
Yep. That's why I still have two jobs. It's kind of like consulting, except now I'm just an employee at two companies part-time each. But I like that. I like doing different stuff.
Yeah. And previously you shared some lessons you learned from your advisor during your PhD. Can you share with our audience?
Sure. My advisor was Maya Gupta at University of Washington, and she was really great. She really, I felt like I was interacting with an actual mentor, a person who really cared about me as a human being and not just as a machine learning output machine. Oh, she taught me a huge amount. My favorite story about that is I think I was very bad at communicating to other people and had no notion that they felt feelings that I should respect. That was, I think, where I was at 22. We're doing a meeting with other grad students, and uh, everyone was talking together at the whiteboard and brainstorming. And what I would do, unfortunately, is if someone's idea I thought was flawed, I would just say that doesn't work, and I just would, I would just say that. There would be no attempt to think how would they feel if I said that. Is that the right thing to say to somebody? What are some ways I could say that this isn't perfect, and maybe like help them develop the idea or work on it further instead of just rejecting it. And afterwards, Maya sat me down and said, "Look, you may be right that that idea doesn't work, but you can't say that to people." And I said, "Why?" Because I was completely ridiculous. And she said, "Well, that makes them feel bad." And I really had to think about that for a while. It's so obvious in retrospect, but I'm glad she did that. I think it really made a big impact on the way I thought about these things. It took me a long time of quietly sitting in meetings and think like, what should I say instead? I had to brainstorm. How do I say this? And it's very important work. I feel like that may have made a bigger difference on my life than all the ML I learned.
Yeah. I think there are different people with different personalities. I remember doing some personality test, like, do you value facts or people's feelings? I used to think, oh, some people lack empathy, or some people are afraid to hurt other feelings. They're not mentally strong enough. And then I realized it's just how our personality works. There's no like kind of absolutely right and wrong about things. And there are some people, they think, oh, if I just tell you you're wrong, I'm trying to be more productive. I'm helping
Yeah,
you. They don't
that's what
think
I
in a
thought.
way that, in the feeling and emotions. And other people would be like, oh, you're hurting my feelings. You're trying to make me feel bad. And they don't think the way of the productivity. I think it's about how to understand how other people pursue feedback and where do they stand in the feeling or like facts kind of spectrum.
Yep. I'm more naturally comfortable in the facts only spectrum, but at this point, I try to make sure to respect other people's feelings. I just
Mhm.
assume people care about, they're sensitive. Everyone's sensitive. I think it's a safe assumption to make, and
Yeah.
it makes other people's lives better. So it's just the right thing to do.
Yeah. I think a lot of data science or engineers, because we get trained in the environment, you're very rational. You need to be right. So when we work with other people, even our personal relationship outside of work, sometimes we'll forget um, maintaining the relationship sometimes is more important than being right.
Oh, totally.
And besides this feedback from your advisor, what are some other, say, books or trainings you start to educate yourself about taking care of other people's emotions or become a better collaborator?
I got really into meditation a long time ago, and I spent a lot of time meditating daily and reading meditation books.
Hmm.
That was very helpful, I think, because it's in some sense it's very self-focused, right? It says, well, here, check out your thoughts, think about what you're doing. But when you look at your own mind very carefully, I think it naturally brings to the mind the question of other people must be having the exact same, complex nonsense in their brain that I am. So I think even though it's self-focused, it helped me think about other people because I just had more time to reflect while meditating, which you're not supposed to necessarily sit around thinking, but it helped a lot. And just general self-help books are good. There's a book called Difficult Conversations I just read that I really liked,
Hmm.
and it's all about you have to talk about a complicated topic that the other person that you might not like their response. What do you do? It's a good sort of first-hand tutorial from these researchers. I really like it. Mostly I read novels. I try. Nonfiction is hard for me to after a long day of nonfiction day job.
Hmm. Yeah. And so now, what do you think about the future of machine learning?
Oh, this is a really strange time to try to think about the future of machine learning. We just had 6 months of wild, improvements, Yeah, like I remember at the beginning I said it's time to put my skeptic identity on the shelf.
Hmm.
I really just feel like I can't predict the future anymore.
Right.
I don't know what's going to change, and it's going to change in rapid and crazy ways. And I'm fully agnostic about the future now. I don't know
Hmm.
at all. What about you? What do you think?
Yeah, I also think this is a really interesting time to ask because ChatGPT just launched, like, I don't know, a few weeks ago. I think in the future, there's going to be some data analysts. Instead of using Excel, SQL, or some tools, they're going to be interface. They can just type in some prompts, and then there will be analysis come out. I think the tools is going to be less and less important, but it's more about how do you understand the data, the problem. Those things will never go away. And there will be more specializations. I think there will definitely be data scientists still writing Python, doing deep learning, doing research. I don't think those things will go away, but there will be a way how people use those tools. I think there will be more, like you said, the Copilot, more assistance. So it would be less barrier to learn a new tool, learn a new algorithm. But again, I think the foundation, the knowledge of statistics, machine learning, those will still be important. Probably more people doing data sciencey stuff. Their title might not be data scientists, and there might be previously product managers or doctors. They have this interface, and then they can write really good prompts and get insights, because data is just like abstract at this point. It could mean numbers, it could mean words, it could mean images, and I don't know what it could mean in the future. And also, I guess my only predictions are similar to you. At this point, things going to change. The speed is like exponentially to compared to previously how we see things. I don't know, how do you prepare for the change, or how do you say if you're mentoring someone who just started their career, what's your advice to them?
Oh, get really comfortable with large language models. That stuff is everywhere.
Hmm.
I'm actively looking for projects where I have to force myself to use them and understand their edges. There's a few projects I've done that and alongside where we're coming up with ways to see if GPT-3 can be helpful. And often the answer is it's not clear, but at least all that work we do, I mean, is interesting. So I think the best advice is understand what's going on and just use them. They're pretty cheap. You can make a GPT-3 account and just start messing around with the playground. And you'll get a bill for $3 at the end of the month or something. It's not a big
Hmm.
deal. But just following tutorials about prompting and understanding that stuff, I think it's very important. But it's also, it might change in a year. Maybe no one's prompting anything or something for whatever crazy reason. But it's good to keep on the bleeding edge of that.
Yeah.
Although if you're, a statistician studying proteins, I don't know how GPT-3 is going to help you. Then again, there are large protein models now. I think in the biomedical world, large models are also being used. They're just not large language
Hmm.
models. So
Yeah.
it seems that there's this encroachment of these models in lots of places. But from what I've seen, it's going to take a while to spread. I'm on Twitter, everything just looks like it's moving crazy, but I think in many industries, it's hard to adopt new
Right.
technologies like this, and
Hmm.
people have their comfortable toolkits that are effective for them. So there's probably a quite long adoption curve, especially for something like this that's external. Like you said, it's going to be like AWS. Yeah, GPT-3 is like AWS. It's somebody else's model, like somebody else's computer. You don't have it in-house. You're relying on them. It's scary. It could be, you hope OpenAI stays around forever. And right now it's looking pretty good for them. But uh,
Yeah.
until they're as big as Amazon, it's still kind of a slightly risky thing to do.
Hmm. And what if I don't work on large data set or large models? My job is helping my company to predict some sales, or I do some classification problems. Just I only work with tabular data. What kind of change in those type of job roles or functions?
It's been fairly stable. The only major differences I've seen are AutoML packages
Hmm.
that you give them a data set and they sort of fit the models for you and figure out the hyperparameters for you, and then you get this huge bundle of ensemble of models. I like those but probably not for the same reason as they're advertised for. At the end of the day, you want something in production that's easy to maintain. Maintaining a giant ensemble of crazy models from 7 packages is not easy. But having a one light GPM model might be doable.
Mm-hmm.
So what I like to do is I like to go through my personal process of fitting a light GPM or XGBoost model, fit a linear model, and then fit one of these ensembles like Auto Gluon or something, and just look at the difference. Like what do I get from a giant ensemble? Is it 2% improvement? If so, I don't care. It's not enough. It's not worth the production effort to have this giant mega model with 50 heads versus my simple model. But maybe the improvement is huge. Maybe I get a large improvement, and that's important because it sort of gives you an upper bound. When you fix your data and your features, you get this upper bound of where the model is failing, and that's just a good thing to know. Then you could
Mm-hmm.
say, okay, light GPM is 10% worse than this ensemble. Why? What in the ensemble is really doing the important work? What's the minimal thing I can add to light GPM to get it really close to that 10%? Do I really need deep learning for this problem? If so, you can provide this data to the folks in the infrastructure team and say, I got to deploy a deep learning model. How do you feel about that? Hey, here's what you get for it. And it lets you understand the effort versus computation versus quality curve. So that's what I use the AutoML models for myself.
Mm. Yeah, that makes sense. I think AutoML is not built for people who don't understand ML at all. I feel if you use that, it's actually pretty dangerous. It's built for people who can use it to be more productive in their job. And you need to understand exactly like you said, where it works, where it doesn't, especially when you compare to the models you build yourself. So when you put them in production or draw some inference from it, you have more confidence. It's not like a black box to you.
Yeah, I'm not that worried about him because my tirade about error analysis. It doesn't matter if you press the fit button. If you don't do error analysis, your model is going to be terrible.
Yeah.
So it doesn't. There's never going to just save you. No model fit without looking at the data and looking at the errors will be good.
Mhm.
That's I can call that my rule. I would love to see that rule violated, but in my experience, it has never happened.
Yeah. Yeah. Also, in my experience, it never happened. You only learn it in textbook in school. You're like, oh, it's so easy. You just train, dot fit, and then everything works out. But in reality, that's just the very beginning of the entire project.
It's a beautiful fairy tale, yeah.
Yeah. So, how do you see your career grow? What are you excited about your future?
I try not to imagine my future career ever. It's always fun to just stumble into the next thing and see what's
Mm-hmm.
going on, but I really want to get better at large language model stuff and do research there. At the Semantic Scholar research team, we are always thinking about what to research next, and this year we're all excited about large language models. I really want to figure out how that stuff can be used and not used. It's really unclear to me right now what it's good at, what it's bad at, what the cost structure is. I think it's fascinating. It surprised a lot of people what these models could do, and I think people are still surprised. Nobody kind of predicted this except the people who trained the model. I think they kind of predicted it, but everyone else is surprised, and that surprise is going to take a while to settle down. We're going to have to really um, mess around, each of us independently, and then put our knowledge together to understand what this stuff can do, cannot do, what its limits are. I'm really excited to work on that.
Yeah. And before we wrap up, is there any other thing you want to share with the audience or any resources, blog post you want people to read?
Oh, yeah, there's a blog post that summarizes the search effort that hopefully we can link.
Yeah.
I think that's it. Yeah, that would be the main one. I think would be interesting for people to look at after this. And if they like
Mhm.
it, I have a bunch of other blog posts on the Semantic Scholar website. There's some papers that we still write occasionally, and they can Google if they're interested.
Mhm. Cool. And where can people find you online?
I have a Twitter account where I don't post very much. I just retweet other funny things I like. I have my consulting website still is kind of a good personal website, although I don't consult much, and that's at data-cowboys.com, and hopefully you'll link to that as well, I think.
Yeah.
I'm on LinkedIn and just Googling me. I'm not the soccer coach, Sergey Feldman, and I'm not the teenager, so I'm the other one. You should be able to.
Cool. Thank you so much for coming to the Data Scientist Show. I learned a lot from our conversation.
Thanks. It was really nice to chat with you.